We're going to take a closer look at this idea of enantiomers in this video. So you've already seen propane used a couple of times as an example of an achiral molecule because it has a plane of symmetry. And what I have here on the right is the mirror image of propane. And of course, if you look at this closely, you see that these two are actually the same. And that's always going to be the case with an achiral molecule. Its mirror image is going to be identical. However, if you look at the other structure that we've been playing around with, where we have chlorine here and we have bromine, hydrogen, and CH3, and we make its mirror image, so chlorine, bromine, hydrogen, CH3, these two are actually different. It's actually maybe a little easier to see that these two are different if you try to stack them on top of each other. And so I have the original image on the top and the mirror image on the bottom. And you could see that if you tried to align them up, that the green is going to be over the gray and the gray here is going to be over the green. So you cannot superimpose them on one another. And so we would call these non-superimposable mirror images. And the term that we use for that is enantiomers. It's a different type of stereoisomer than we've seen so far. So if we have a chiral molecule like the one here with 4 different groups about it, and we want to draw its non-superimposable mirror image that we call its enantiomer, we're going to pretend like we have a mirror that's drawn in purple here, and we're going to draw the molecule's reflection. And so if I were drawing the reflection, I would see I have CH3 groups reflecting here. I have a fluorine at this position. I have an oxygen, an OH group at this position, and then finally going out away, I have the hydrogen. So this is the enantiomer of the structure in yellow. Let's try another one. This time we're doing a cyclic structure in the chair conformation, and I'm going to draw my mirror there, so to speak, and I'm going to draw the mirror image that would be reflected. If I'm looking at it here, I see chlorine facing into that chlorine, an OH group straight down, and so this would be the structure in purple is the mirror image or the enantiomer of the structure in yellow.